Hello pre-calculus students, and welcome to a video on properties of functions. We're going to look at properties that we can see from the graph of a function, so we're not looking at equations for this lesson. And the two things that we're basically looking at here are looking at first, where is a function increasing, decreasing, or constant? And the second thing we're going to be looking at is what are the maxes and min. So you've got two kinds. You've got a local max and absolute max, and then a local min and absolute min. All right, so let's first talk about increasing, decreasing, and constant. All right, so we're looking at a function here. And before we answer the question up above on what kind of intervals here, let's just kind of look at what we have here. So we have a function that's decreasing from x equals -6 until it gets to x equals -4. So from here to here, the function is decreasing. And then starting at -4 and all the way up to 0. Now this is a common mistake that students make. They see a point. Now just don't do this. Okay, you see a point on the graph and you say, oh, it's increasing from -2 to from -4 to -2. And look, it's also increasing from -2 to 0. Well, why break it up like that? And I don't want you to break it up like that. If it's increasing on an interval, I don't want you to break that up into more than one interval. It is increasing all the way from x equals -4 until x equals 0. From the point of the value of -2 up to 4. So it's increasing on this entire interval. And then it stays constant for a while from 0 to 3. So up to here, the function is constant. And then it decreases from 3 to 6. Up to 6. Okay. Now the reason, the thing that you want to look at here is what's actually happening at, let's say, at this point right here, when x equals 3. Well, we don't want to say that it's constant and it's decreasing. We really want to say it's not really doing either. It's kind of between where it's constant and it's decreasing. That's the one point in between. So when we write these intervals, I'm not going to include the 3 in my interval, and I'm not going to include the 0 either. It's going to be constant from 0 to 4 as an open interval. The same is true for all of these, and that's the part up here that I left out because I wanted you to understand why first. Functions can only increase, decrease, or be constant on open intervals. No closed intervals there. All right, so it's going to be decreasing from on the interval from -6 all the way to -4. It's going to be increasing from -4. This is from x equals -4 until x equals 0. So from -4 to 0. And then it's going to be decreasing again from 3 to 6. Okay, so those are the intervals where it's increasing, decreasing, and constant. We can write that out, right underneath these little visuals to help us remember what they mean. Increasing is always from left to right, but here, so it's increasing on the interval from -4 to 0, and that's the only place it's increasing. It's constant on the interval from 0 to 4. And it's decreasing on two intervals from -6 to -4, and also from 3 to 6. Okay? When we're talking about where a function is increasing or decreasing, we don't talk about ordered pairs. We talk about the x values, the inputs. Okay? The next topic here is local max, and let's just talk about the difference between the local and the absolute maximum, and then it's pretty much the same idea for the minimum. So the local maximum, notice in this picture, it's got like a curve. It's got a top point of the curve. And local maximums have to be, and this is the key, they have to be on intervals. This is just the way they're defined. So it's not a local maximum unless it is the highest point on an interval. In other words, unless there's something on both sides of that maximum that are lower. They've got to be lower or it's not a local maximum. For that reason, you cannot have an end point be a local maximum because there's got to be something on both sides of the point. However, there can be more than one local maximum on a graph. Okay, compare that to absolute maximums. Nothing to do with intervals. It's just the highest point on a graph if you know it. You don't always know it. And there can only be one highest point on a graph. So there's only one. There can't be two absolute maximums. All right, and then the minimums follow the same exact ideas. The local minimum is the lowest point on an interval. It can't be an endpoint. There can be more than one local minimum on a graph. While the absolute minimum, it can be an endpoint, but there can be only one of them on a graph. Okay, so we're going to look at a graph here, and the directions say just to find the local and absolute maxima and minima, and that's just, I put that in parentheses here, but that's just another way of saying maximum. All right, so let's look at this graph. Okay, so first of all, when you're looking, let's look at the locals. Okay, so the locals are the tops and bottoms of hills. So this right here, this point right here is a local minimum. Okay, here's another local minimum, because it's also the bottom of a hill. All right, so we would say, there's a lot of ways to say it. You can say there's a local minimum at -1 of 1, because the height is 1. And here there's a local minimum at 3 of 0. You can also say there's a local minimum that is f of -1 equals 1. And you could say here that there's a local minimum that f of 3 equals 0. Okay, so there's two local mins. There's one local max. So this right here is a local max. So let's just put this up here. There's a local max. And let's just go with the second option because I think that's the one that your book uses. There's a local max where f of 1 equals 2. Okay, now let's talk absolute. There is no absolute max. There is on this side, but at the entire graph, there's no highest point because the arrow goes up forever. So there's no absolute max. Okay, there is an absolute min. There is a very lowest point, and it happens to be the same point as the local min here. This is also an absolute min. And we'll just say f of, same thing we said here, f of 3 equals 0. At f of 3, and that's of 0. Okay, so there's an example that has a couple local mins, one local max, no absolute max because of the arrow, and one of the local mins is also the lowest point. Let's look at the next one. All right, let's just take a minute, pause the video, think about this, and see if you can figure out local max, local min, absolute max, and absolute min. Okay, let's pause the video and I'll write down the answers, see if you can get the same answers. Okay, that was fun. There's none of any of them. So let's talk about why. Okay, let's first look for a local max. There's no top of a hill like there is here. There's no top part where it's lower on both sides. So there's no local max. There would be a local min if only there was a point there, but at the very lowest point where this looks like it could be a local min, there's a hole there. There's no actual point there. So that 3, 2 represents a hole, not a point, and so there's no local min. Now what about absolute max? So the absolute max is ruined because of the arrow here. It says it's going up. It looks like it's asymptotic, but it's going to go up forever. Okay, so there's no local max. As far as absolute max. As far as an absolute min, there's no lowest point. Nobody can say what is the lowest y value on this graph. You can say that it's just a little bit higher than 2, but you can't say what it actually is. You can't say 2.1 because there's also 2.001 that's even lower. So there is no lowest point on this graph. Okay, so that's where there's no local or absolute min. It's the same reason for local and absolute, actually. Okay. Here's another graph, and while this has clearly there's no absolute maximum, it goes up, And there is also no local maximum. There's no hills of any kind, so there's no local or absolute max. No local or absolute max. And as far as the min, while there's no local min, there is an absolute min. So there's no local min, but there is an absolute min. That's f of 0 equals 0. Okay, so we'd say there's an absolute min at 0 with a value of 0. Okay, I hope you found this video helpful.